This is Bob Capetta, a professor of mathematics from College of DuPage in Glen Ellen, Illinois. And here we're going to look at the 5-number summary and box plots for a discussion in the Math for Health Science classes. Now, what is a 5-number summary? We have a large data set. It's difficult to describe a large data set unless you look at a few numbers that represent its behavior. And if we want to know about the spread in a data set, we construct what's called a 5-number summary. And looking at that, the 5-number summary consists of the minimum, Q1, which stands for the first quartile, the median, Q3, which is the third quartile, and the maximum. Well, the first quartile has to be better than or higher than 25% of the rest of the data. So by definition, that's the 25th percentile. The median is the number that is directly in the middle of the data set. So if the number is in the middle of the data set, that is the median. That is the 50th percentile. Half are lower, half are higher. Q3 corresponds to the 75th percentile, so Q3 is higher than 75% of the data, 75th percentile, and then the maximum, of course, is the largest number that we're working with. And we use the 5-number summary to give us a visual representation of the spread in that data set. And that visual representation is called a box plot. Now, how do we construct one of those representations? Well, we draw a box that goes from Q1 to Q3. And at the median, in the middle of that box, we put a line representing the median. And then from that box, we have whiskers. Whiskers extend from Q1 to the minimum, and the whiskers extend from Q3 to the maximum. So, just looking online, we find a box plot for some representation of men versus women for some sort of a data set. So these numbers represent the minimum. Those are the whiskers. Q1 for women would be here. That's the 25th percentile for women. 25th percentile for men would be here. The median is the line in the middle of the box plot. There it is for men and for women. Q3 is the 75th percentile, better than 75% of the data. Women here, men here. And then, of course, extending out to the maximum value for women, maximum value for men. So back to our data, we looked at the diabetes weight data in the previous video, and we had a minimum of 99, the 25th percentile, which we now can call quartile 1 of 151, median of 172.5, Q3 of 200, and a maximum of 325. And this is easy enough to draw by hand, but I will go ahead and use technology to enable the draw. At the top of the page, I hope you can see the URL, www.imaths.com/stattools/boxplot.html. Now we are drawing one box plot here to represent the weights of the entirety of that collection of individuals in the diabetes data. So we can call it weights. The minimum number that we had for our group was 99 pounds. Q1, 25th percentile, was 151. The median of this was 172.5. Q3, the 75th percentile, was 200. And the maximum was 325. Now, to get a decent graph, we want to start with a reasonable minimum, and I would say 0 is probably okay. Maximum is 400. Distance between the tick marks, maybe 50. Not that it's terribly important. What we're measuring here is pounds, and those numbers I assume are okay. If we hit graph, the applet will go ahead and give us a visual for the data that we're working with here. So you can see the tick marks on the bottom representing pounds. Weights of individuals are what we're looking at here. You can see the median of 172.5 is in the middle, 151 is here, 200 is here. The whisker goes all the way down to the minimum of 99. The whisker goes all the way to the maximum of 325. So this gives us a visual representation of the data to describe the behavior, recognizing that half of the people, the middle box represents the middle 50%, range from 151 pounds to 200 pounds. So that gives us an idea about how the data behaves. Now, of course, this combines men and women, and I'm not sure that's reasonable because we would expect men and women would come from two very different populations with respect to weight. So let's return to the Excel spreadsheet and let's separate out the men and women and go from there. We want to sort the data. The gender column will enable us to do that. So we'll click on gender and then go to sort. So the data button is the one we need to sort, and we can sort that either ascending or descending, and I always like to expand the selection so that all of the rows stay the same. We just change their order. And notice you'll notice all of the women are together. So I suggest you copy all of the women's numbers, set them aside, and then we'll see where the men start. You'll notice here's where the men start. I'll get there in a minute here. Copy all of the men's numbers and set them aside, and then we'll go ahead and work with those. I have all of the men in the first category, and I have all of the women in the second category. Where I had height before, I erased height and I put a locator to tell us how many men and how many women we have. So that's probably important for us. And from this, we want to generate our 5-number summary. Our 5-number summary being min, Q1, median, Q3, and maximum. So let's have some room to work with those. So let's go ahead and do that. We're going to have min, Q1, median, Q3, and the maximum. And we're going to need that 5-number summary both for men and for women. Well, the minimum weights are certainly easy for us to see. The man of minimum weight is 100 pounds, very small man, woman at 99. If we want the maximums, let's go ahead and go to the bottom of these lists. The maximum man is 320 pounds, as we see here, and the maximum woman is 325. So we'll add those in. Maximum man, 320. Maximum woman, 325. Now, to find Q1, 25th percentile, median, 50th percentile, Q3, 75th percentile, we will need to know the ends. So what are my sample sizes? How many men do we have in our list here? Our list includes 168 men. Write that down. And how many women do we have then? A few more women. The number of women in our list is 234. So in order to find Q1, what do we have to do? For the men, it's going to be 0.25 times n, 0.25 times 168. And what does 0.25 times 168 give us? 42. Now, that is a whole number. So we've got to take the average of the 42nd and 43rd person. So in the men, 42nd and 43rd, both 159, hence the average 159. For the women, to get Q1, what would we do? For the women for Q1, we would take 0.25 times 234. And what does that give us? 0.25 times 234 is 58.5. Now that we can just round up. We can round 58.5 up to 59. Who is the 59th woman in the list? The 59th woman in the list is 145. Now to get the median, we take half, 0.5, and the men's n is 168. 0.5 times 168. What is that going to be? 84. So we have to average, because that's a whole number. We're going to go to the 84th man. 84th man. Take half of the 84th and the 85th. Well, they're both the same. They're both 178, so that's not a problem. The average of 178 and 178 is 178. For the women, for the median, what are we going to do? We're going to take 0.5 times 234, And what is that going to give us? It gives us 117. Again, a whole number, so we'll have to average the 117th and the 118th. So we'll look in the list of women. 117th, 118th. What do we get? 170, 170. 170 it is. So the median for women is 170. And then we'll finish with Q3, which is our 75th percentile. That's going to be 0.75 times how many men do we have? 168. 0.75 times 168 is 126. So we'll have to average 126 and 127 for the men. 126 and 127, both 204 in that group. And then for the women, we will take 0.75 times the total number of women is 234. 0.75 times 234 is going to give us 175.5, which we can round up to 176. We find the 176th woman in our list. 176th woman in our list is 200. So we have our 5-number summary. We have our 5-number summary for the men: 100, 159, 178, 204, 320. We have our 5-number summary for the women: 99, 145, 170, 200, 325. Frankly, the two data sets are pretty similar, so the box plots will also look fairly similar. So we'll go back to our internet application and draw the side-by-side box plots for the men and the women in this category. So 2 box plots this time, and the internet app allows us to do 2 side-by-side box plots. So the first one will do the weights of the men, and the men minimum was 100. Q1 was 159. The median was 178. Q3 was 204, and the maximum was 320. And the next group we will say weights of women. The minimum for the women was 99. Q1 was 145. Median was 170. Q3 was 200. So you notice in each instance, the men have a higher weight. Minimum is higher just by 1 pound. Q1 higher by quite a bit. Median a little bit higher. Q3 a little bit higher. Maximum, 1 individual, obviously, is driving the maximum for women. Let's go ahead and do this. So our overall min 0, overall max 400, tick marks 50, that sounds decent. Axis title pounds. Let's draw these 2 box plots called side-by-side block box plots on the same scale so we can see how they compare to each other. And there you see it. We have the men in the first position, the women on the second. So in general, the men tend to be a little bit heavier, with the exception of the largest individual in the collection. And that will conclude this lesson.